What we're going to do today is a little bit different than what was advertised, because my laptop computer died yesterday. Not totally died, but the screen is very fuzzy and I can't do anything with it. So I quickly cobbled something together that kind of approximates what was in the abstract. We're going to spend a little more time talking about what a natural law is, and possibly a little less time on the range of future histories and mass beam propulsion, though I did manage to find a copy of that one mass beam propulsion PERT chart that I wanted to show. A future history is roughly a time-ordered background for a series of science fiction stories. The term was coined by Astounding editor John W. Campbell. Astounding is the magazine that changed its name to become Analog, and so that's the one that I've published a fair amount in. The term, it was coined by Campbell for the chart that Robert Heinlein used to organize a series of his stories that shared a common background. Some others who have created future history comprising a number of stories include Olaf Stapleton, Last and First Men, Isaac Asimov's Foundation series, Poul Anderson with the Polysol Technic League, and Flandry of Terra, the Empire following it, C.J. Cherry's Down Below Station series, and last but not least, I've done my own, kind of beginning with Miranda Rift, but there are others in there. This talk concerns possible future histories that are rooted in real history and real laws of nature. And I'll be using Heinlein's future history as an example as well as my own. And this is going to go a little bit slower on this because I have to do it this way. There wasn't... Oh, please.
Rotate. That's okay. We'll go sideways. Clockwise, yes. No.
There we go. There we go. The purpose of a future history is to provide a consistent background for fiction. Real history is too contingent for anything better than a ballpark anticipation, and real history is often not exciting enough for entertainment purposes. So often future histories will contain some exciting things that aren't maybe very probable. Some future history does try to provide a plausible and relevant background, and I try to do that. And the reason is that if somebody looks at my stuff 50 years ago, like we look at what Jules Verne wrote or H.G. Wells, they say, okay, that guy had something to say, and maybe still have to say, even though the details have been different. And my standard is, well, maybe this could happen this way. And the process of creating a future history can anticipate some kinds of events in different places and different circumstances. They often extrapolate trends in established history. And in that way, if you do it right, somebody reading your story can recognize where that future history came from. Every now and then, something develops in a way that reminds us of something in a fictional future history. And we'll see more of that in the anticipation part of the lecture. Also note that science fiction future history contains things that an author does not want to happen, quite often. Heinlein's Future History, for instance, contains the takeover of the United States by a religious dictatorship. You write something like that because you hope it'll scare people into behaving so that it doesn't happen. Okay, and this is the anticipation lecture, which I did have in a place off my laptop. This is my wife's laptop. Full screen mode. There we go. And what I'm going to talk about is anticipation and the laws of nature. The idea being that if you're going to do a good job of anticipation, you should play within the laws of nature. A law of nature is something that always happens within the measurement of accuracy and range of observations. It's empirical. Frequently it's expressed in an algebraic equation, but we've got to remember, and I'll show you later, but this is an example of a law of nature. The distance traveled is proportional to the time squared for something moving under gravity.
Yes, it is.
Here you
Oh
go.
man, you're a gentleman and a scholar.
There. Working on the latter. Let's see. Boyle's and Charles' laws are laws of nature. Okay, yeah, all right. Let's see. I don't need the hat. Okay, if you can't hear me well, I'll just speak a little bit louder in the speaking voice. The idea behind Boyle's and Charles' law is that the pressure is directly proportional to temperature and inversely proportional to volume. Increase the temperature and the pressure increases. Increase the volume and the pressure decreases. Empirical equations for this are here, and people that are familiar with equations get it immediately, and the rest of you, this is not the time and place, I guess. But there's also a theory that goes along with Boyle's and Charles' law, the movement of particles and such, and there's this equation. The range, this classical glass, doesn't really work well in liquids and solids, plasma, or the quantum level. Conservation of energy and momentum. That's a natural law. The total energy and momentum are the same before and after any event. And you have various equations. The one I'm going to put out here is Einstein's that the kinetic energy squared equals the momentum squared times the speed of light squared minus the mass times the speed of light squared, the quantity squared. Range, this works from subnuclear particles to galaxies. It doesn't work as yet for dark energy. Lorentz invariance. The time and distance intervals appear different on objects moving with respect to an observer in a way that makes the speed of light and Maxwell's equations stay the same. That's as simple as if you're driving along in your car and you measure the speed of light, it's exactly the same as it would be if you were standing on the side of the road and measuring the speed of light. The speed of light is the same in all frames of reference. They had a lot of trouble with this at the end of the 19th century. And they tried this formula and that formula and the other formula to try and get Maxwell's equations to work in the moving frame of reference. And what they came up with is called the Lorentz transformation. Einstein came up with the same thing by going directly from the observation that the speed of light is the same in all frames of reference. And he found that he could derive these equations from that postulate, which is very interesting. The range, this works from nuclear to universal, and doesn't work yet at the quantum level, but that's still a work in progress. And I was going to mention the Lady Bright problem. Does everybody know the Lady Bright limerick?
No.
There once was a lady named Bright, whose speed was much faster than light. She went out one day in a relative way and came back the previous night. It's exactly correct that if you go faster than light, you're going in one frame of reference, you can go backwards in time in the other frame of reference. And if you return at the same superluminal speed, you can arrive before you departed. That is a consequence of this Lorentz transformation. This and not infinite weight gain as you get close to the speed of light or something of that nature is what the real problem is for faster than light travel. It creates causality contradictions. Faster than light travel is time travel. And this is why I don't use it in my future history, because if you can have faster than light travel, all sorts of things can happen that can't happen. And it loses relevance. That's not how the universe works. I will be happy to answer more questions about this, but I'm going to try and stay on time track here. The thing I would like to point out is that the equations we fit to observation of nature are not the laws themselves. They're a picture we make of the laws. They're a mathematical picture. Ceci n'est pas une loi de nature. Does everybody know this Magritte painting, very famous one? No, this is not a pipe, it's a picture of a pipe. And that's important. You can't overthrow a law of nature by attacking a model, nor the physicist who replicates it. All of the data, all those observations that went into getting these equations, which these equations fit, are still there. You would have to fit the same equations. You get saying that Einstein might have been wrong, or we're going to have a new theory that's going to no. You got all the data. You got the law of nature that fits the data, and within the range of the observations, that's always going to be that way. So some laws, observations on laws of nature. The laws of nature come from observations, not theories. They're empirical. They can't be changed by changing theories. Whatever other mathematical model is going to have to reduce to the same thing. It's going to have to reproduce the same data, because the data is already there. It's taken, it's observed, it's written down, it's recorded. Theories that extend beyond the range of observations can be wrong. That doesn't change the data within the range of observations. As far as interstellar travel is concerned, the range of observations is well within what we've got as far as Lorentz invariance. I mean, the stars move at velocities of maybe 30 to 100 kilometers per second relative to each other. That regime has been very well explored. Laws of nature are immune to future engineering or scientific discovery. That's because you can't change you aren't going to, the observations are there. And that's like saying you're going to find Alexandria wasn't in Egypt. And they constitute, therefore, a constraint on what can be done in the future, and constraint on what can happen in the future, which is why it's relevant to this discussion of future histories. Assuming you're going to make a future history that is actually a real, plausibly real future history as opposed to a fantasy. Now, in science fiction, people write for different reasons. Some of us try to explore the possible future. Some of them are just making displaced comments on the present. They don't care about whether the future or their whatever their story is really plausible or not. They Alice in Wonderland is an example. They have something they want to say about the present that's displaced into this future. And others want to just relive an exciting past. They'll take the British Navy of Horatio Hornblower and pop it into the 22nd century with a little window dressing, and there you go. But you're dealing with 19th century history, not 22nd, not a possible 22nd century future history. H.G. Wells said that all of them should have some understanding of the laws of nature we know. A violation of a law of nature should be deliberate, not a result of bad research. Nothing remains interesting where anything may happen. As soon as the magic trick has been done, the whole business of the fantasy writer is to keep everything else human and real. Touches of prosaic detail are imperative in a rigorous adherence to the hypothesis. An extra fantasy outside the cardinal assumption immediately gives a touch of irresponsible silliness to the invention. Okay, some more on anticipation, and this is the S-curve. How many of you have heard of the S-curve before? Okay, we got a few, yeah. If you have some measure of time and effort, it might be money or so forth, going this way, you have a measure of performance going that way. You start out, it takes a lot of time and effort to get any increase in performance. Then suddenly you start figuring out what you're doing, and the performance increase become very rapid with time and effort until you start approaching this physical limit up here. There's only so much you can do this thing, and that is the top of the S-curve. You see this sort of looks like an S. If you rotate it 45 degrees, it'll look more like an S. But that's why they call it an S-curve. Household lighting. For millennia we were using torches, then we got candles, we got gas lights, the Edison came along, then we have fluorescent lights, and then we have compact fluorescents, and now we're doing LEDs. And we're at the point where we're getting about all of the electrical energy we put into the device out as light. You can't do any better than that. I think most of you know when the LEDs came along, well, should I change out my compact fluorescence for an LED, there's not that much savings, but as they wear out, you do. That's the kind of thing. In subsonic aircraft, it took a while to get beyond this up to the Ford Tri-Motor, and then all of a sudden you're into something that looks streamlined and like that, and like the, and I love this plane, the Super Constellation. That's my favorite airplane. Then you get the 707, and then you get your, I don't know what this is, probably a 787. Thing is, this has been like 50 years, and the shape of a subsonic airliner has hardly changed. You've reached the physical limit, which is kind of the speed of sound. You need a kind of an entirely different shape of airplane, a kind of different kind of airplane to do supersonic efficiently, and we're still working on that one. This guy is Francis Bacon, lived almost 400 years ago. He wrote was arguably the first science fiction story. It was called New Atlantis. It's about novella length, and he didn't quite finish it before he died, but they published it anyway because it had so many interesting ideas. And he, at the end of it, I don't know what he would have eventually intended, had a list of what he called sort of the gifts of nature. These are what human beings get from learning the laws of nature, he thought. He was thinking of the engineering. He didn't know how to do all of these things, but he knew that if the human body and nature was a mechanism, we could, by experimenting, figure out that mechanism and figure out how to use it to accomplish the things we wanted to do. So he's talking about prolongation of life, restitution of youth, retardation of age, curing of diseases, increasing of strength and activity, mitigation of pain, increasing of ability to suffer torture or pain. As a military guy, well, yeah, that'd be a good thing. The altering of complexions, fatness, leanness, altering of stature. We can kind of do some of this now. We're getting better at it, increasing and exalting of the intellectual parts. Wouldn't it be nice not to forget things? Versions about this is archaic English. It means transplants, basically. Making of new species. With CRISPR, we can do that now. Transplanting of one species into another. We are doing that now. Instruments of destruction as of war and poison. We've certainly been doing that. Feeling better. Force of imagination, either upon another body or the body itself. And that sounds sort of woo-woo, but we're able to read brain waves and cause little dots to go up and down on the screen. I mean, if I had enough money, I could have gotten something like that and come here and sat here and thought and have the slides change for you, and so on. That we're doing that, and we're getting better at it. Acceleration of time and maturations. Wouldn't you want that shade tree to grow up in a year instead of, taking 5 years? Impressions on the air and raising of tempests. We could use that. Global warming is a problem, the effects of it. Turning crude and watery substances into oily and unctuous substances. Elon Musk is looking at being able to turn water and carbon dioxide on Mars into rocket fuel. So people that go there can come home. Drawing on new foods out of substances not now in use, impossible burgers, making new threads of apparel. Okay, well, we've crossed that bridge, nylon and all kinds of things, and we're getting better at it. Composite materials, deceptions of the senses. We're unfortunately getting very good at that as well. Greater pleasure of the senses, yep. And artificial minerals and cements and all of that, which sounds sort of prosaic, but boy, back in the 1600s, the early 1600s, they could use some of that. I like going through this because you compare this guy's imagination and what he could see ahead in the future to some of our science fiction writers who maybe change just one thing and leave the rest of everything else the same. Okay, some the S-curve lessons. Engineering difficulties are not laws of nature, not constraints on the present or future. They may still have a lot to be done regarding what is done and when, and when the S-curve plateaus, maybe decades, centuries, or maybe never, if there is a better way. I think I should have rewritten that slide. Anyway, one should avoid thinking something can't be done because it hasn't been done, or can't show how it can be done. Arguments of personal incredulity are non sequitur. An argument of personal incredulity. I can't believe that such and such will, I can't believe that people will ever travel faster than 20 miles an hour. I can't believe, and another thing is you should not discount everything because it would change everything. You should not discount something because it could change everything. We're going to talk about robotic manufacture, robots that can make copies of themselves as well as make some sort of mechanism or product or whatnot. And that leads to an exponential increase of product, as much as you want, and all they need is raw materials and somebody to tell them to do it. What is that going to do to economics? You say, I can't deal with that, so I'm going to ignore it. Probably not the thing to do. You want to try and think like Bacon, Franklin, Verne, Fermi, Clark, Dyson. Try and see that, okay, this is what can be done with stuff. And somebody is sooner or later is going to figure out how to do it. So our job, perhaps philosophical moralists or whatnot, ethicists, is to get in the head of that power curve and see, okay, how are we going to do that? How are we going to control that? How are we going to adapt to it? This is Earth. This is the Apollo 13. And this is Verne's Columbiad. And here's the moon. Aluminum capsules, 3 people each. As impossible as the future is to predict, that's getting pretty good. We may have new natural laws and new constraints and possibilities. Dark energy, dark matter, Planck scale stuff that we can't quite get a handle on yet. And in areas that we see nature doing something curious, but we don't have the full story. as what's going on with the expansion of the universe. And a number of articles now that we think we know, we measure it one way, it's expanding this fast. We measure it another way, it's expanding that fast. What's going on there, and that may tell us something that's going to be useful at some point. The takeaway, laws of nature are what nature always does. Violate them and you're writing fantasy. Theory is fit to nature, not vice versa. Overthrowing theories doesn't change the data, it doesn't change the law of nature. They both enable and constrain. There are things you can do and there are things you can't do. They're not necessarily things that you've already done and somebody hasn't done yet, but there are possibilities and limits. And new laws of nature are to be constructed, but they won't change the data either. So you do the research and think. As world builders, futurists, ETI searchers, grant us the courage to anticipate what can be, the equanimity to accept what cannot, and the wisdom to know the difference. That's from paraphrasing the AIAA, and this is, if you can't quite read that, King Canute and the Tide. And the story is that King Canute's subjects were so enamored with him, they say, anything he says, he could do anything. And he says, well, I can't command the tide not to come in. And he had them bring a throne down to the seashore, command the tide don't come in, and it came in. And he says, see, I told you so. Imagine Donald Trump having that modesty. Okay. Okay. All right. As promised, this is the. I think we can go to full screen mode here because this is going to be a little bit. I don't know if you can quite see this, but the notion here is that in this case I had a goal. I was asked to write a paper on mass beam propulsion for the 100-year Starship program. Somebody had gotten some money, I think DARPA and all of that, and say, okay, let's see what we can do in 100 years. And okay. So, working backwards, and that's always a good way to go, something like this. How long does it take to get to Alpha Centauri? Well, even if you're going near the speed of light, that's about 4.5 years or so. So you got to back off that much, and then you're going to want to go there first, maybe a little slower, to see if you can. Maybe set up some infrastructure, so you back that off. So you're going to need your propulsion system down here about 2080. You're going to need a lot of energy, several times the total non-food energy use of the human race right now. So how are you going to get that? And that's where we get into self-replicating machines that can reproduce copies of themselves, make solar power satellites and beam stations, and double, say every year, you get another gigawatt or 2 gigawatts or whatnot. And if you do that, you find you get enough energy to push a starship up near the speed of light in 20 or 30 years, thereabouts, depending on what you choose for the doubling period. But the first thing you have to do is make the things that make copies of themselves as they make the thing you're trying to make. There's work going on in that, and there are people trying to figure out how to mine asteroids cheaply. All sorts of stuff being done on that. On the chart here, I thought maybe 2045 we would start getting to do that. we do, and I find that there are people looking at mining asteroids. There are some premature efforts, but they're getting better at it. You need to, in a beam propulsion, mass beam propulsion, what you have is you have a sail, and you throw things at the sail. And instead of carrying all sorts of fuel or bombs or whatever on your spaceship, all you have is a sail and the additional things to take care of you when you get there. And you keep all of the fuel and the propulsion mechanism and all of that here, and you throw the stuff at the sail. That's how mass beam propulsion works. I can talk more about that. I can talk very long on that, but not here right now. You need to get beam drivers and all of that, and the traditional way of going out is you go out and you start a program and you ask for billions of dollars and do this and all of that. And, I don't have billions of dollars to, that's not plausible for star travel at this point in time. But let's look at what's happening anyway. And the computer stuff is happening, the nanotechnology is happening, the interest in asteroid resources is happening, and all of that. So I don't really have to, until maybe 2040, 2050 or so, do anything specifically for interstellar propulsion, because it's all getting done anyway. Now, someone that's a little more aggressive than I did came along, and has anybody heard of the Breakthrough Starshot? Okay, what they're doing is they're going to gang up a whole bunch of lasers and have little tiny sails that are full of microchips and stuff. They can build that really small now. They're going to push the sails with light or microwaves up to a tenth or 2/10 the speed of light, and send them on to Alpha Centauri to report back what they found. Okay, there are a lot of engineering problems to solve on the way, but all I'm interested in is that pushing them up to near the speed of light. Because a good friend of mine who's no longer with us, named Jordan Hare, looked at mass beam propulsion, and he thought, okay, the mass that you push the sails with, those can be little sails. So the idea is you push little sails with lasers at very high acceleration, and they hit your spacecraft and push that. So the two-step process eliminates a whole bunch of problems in infrastructure, and they're already doing that. And even if it doesn't fly, the idea has been put into the public, and it's happening. Okay, that was a standalone. I need to get to future history charts. This stuff shouldn't be there. Here's, oh, come on. There we go. Okay, this is very hard to read, I think, for you. There's another way of doing this. We'll just look at this part of the chart here, and what Heinlein has done is he listed his stories here. Here are the characters in the stories, where they lived when they were born and died. And then he found a lot of the technical things. Let's see if I can... These are the sun power screens. Mechanized roads. Heinlein had the idea that instead of having hundreds of cars on roads, that you actually make conveyor belts. And they go a little, you step on them, they're going slow at the start, and they go faster and faster and faster until you get to the middle where they're going like 60 miles an hour or so. And you just stand there, or maybe there's a drink stand there or something like that, and they whisk you off to wherever you're going, and then you do the reverse process, going to slower and slower tracks until you can step off until you're there. And he wrote a story called "The Roads Must Roll," and the idea was, okay, what happens if there's a strike? Yeah, and that's what the story is about. It's a good story. Here's some more of the technology he came up with, and here are some of the result as a sociological comment. He had the crazy years. The year he chose for the crazy years was not exactly 1968, but it was close enough. How many of you remember 1968? All sorts of weird stuff happening. Heinlein's story ends with the sun going nova. That didn't happen. We're still here. But he was looking at various trends, cyclic trends, and all of that, and was wondering what happened if they all happened to come together at once. And what he ended up with was not a bad. Yeah, it was 1968 in so many words. Then he goes on. You have Luna City founded. You had the man who sold the moon. This was lunar exploration done by a 3-stage, 4-stage rocket. He went through what could he have done, and he was working with 1940s technology and a little bit of imagination, and he came up with something that was very much like a Saturn V. And the difference in his future history and our future history is when the guy came back, he came back with a pail full of diamonds. So all of a sudden there was a lot more interested in going to the moon and staying on the moon back then. Let's see, where did I see? Yeah, strike of 76, that's what happened with the roads. First rocket to the moon. And then he had something, the rise of religious fanaticism, the New Crusade, and if you look at past history, you have all of these black swans. You have these contingent events that seem to change everything. Well, there are going to be some of those in the future too. We don't know what they are. If you're going to do a plausible future history, though, you throw one or two of them in. What Heinlein thought of was you pick the name. One of these holy rollers involved in politics, Jerry Falwell's type or something like that. And he gets elected president and establishes the new crusade, and that's the end of democracy. It's not exactly what's going on right now, but it's close enough to scare you. Going beyond that, in here there's a revolution. Let's see, one of the story, which won a retro Hugo, which is a, okay, there we go. If This Goes On. And that's the story of how Americans finally got together and overthrew that religious dictatorship. I strongly recommend that story. That's how Heinlein laid out his future history. The stories, the characters, the technology, future technology, when he thought that would come on. And he called, at the end here, the first human civilization, which is what developed after the religious dictatorship got overthrown and the whole world was sick and tired of that stuff and came up with a nice government system. And reestablishment of civil liberty, renaissance of scientific research, resumption of space travel, Luna City refounded, all of that. So recovery and consolidation eventually of the whole solar system. It didn't happen exactly that way, and there's some of it that's still in the future, but this is the prototypical science fictional future history. This is the future history that Campbell coined the term for. And it's in his book, The Past Through Tomorrow. Okay. And again, we don't seem to navigation is a little bit difficult here. Not really time to test this out much. But what I've done is I've kind of come up with a thread of major events. And this isn't all future history. I start with the real history, and I have some stories that are set in the real history. I also, because I've been writing for 25 years now, science fiction stories, and some of them were near-term science fiction stories, the future has kind of caught up and passed the story. And some of them have events in them that can't possibly happen now because history didn't go in that direction. Others, I got a little luckier. I have one story about the guy that invents a camera, a microscopic camera that can image and reproduce in a 3D model the grooves of a record. His problem was his father was a part-time opera singer, and the story's called His Father's Voice, and there's only one record, pressed record left that has his father singing on it, and it's broken. So he invents a way of hearing his father's voice by imaging all the grooves on the record and playing them with a virtual needle. Okay, that was 20 years ago. I wrote that. The guys up at Berkeley have managed to do that. It hasn't hit the market yet as a way of playing vinyl records, but maybe any day now. So I took the same story, and we had our Sunnyvale Library was having an anthology. And they said, can you submit a story for the anthology? And I said, okay, I just submit that one as a nonfiction Silicon Valley story. It sold. So that was one that, it was science fiction when I wrote it, and not science fiction the second time I sold it, but really the same story. That's getting lucky. At any rate, I have the history. I have the technology. What your are things like Gecko. We don't quite have it yet. I think people are working on it. You know how Velcro works? Yeah. Gecko would be like one-sided Velcro. Your little tiny hooks that you put on pretty much anything and it will stay there without stickum or chemicals or anything like that. And they're getting close to that. We have our space colonies. I'm putting that around 2045 or so. Nanotech refiner printers. What I need for the interstellar exploration for making all of those solar power stations to push the starships is the self-reproducing thing. I think he's saying 10 minutes, right? Actually, I expect to not really have much more to say about this now. It's just my own stuff, and the point of the slide is what the process was. Is you work things out, and these are the stories. And it was sort of a iterative process. I wrote some stories without actually intending to do a future history, but since it was easier to sort of stick with the same the same kind of technology and all of that, the first 5 or 6, and then I kind of did a history to work with those, and then I filled in some more stories and more dates and more people and all of that until you have the monster that's on the screen here. And it's not perfectly consistent because I didn't set out to do it this way, but it's reasonably consistent, and just about everything in here I try to stay true to physics. There's no magic in it. There's no faster than light travel. There's no stuff that can't happen. And I tried to deal with plausible events. And I don't have and a lot of writers will do this. They'll wipe out civilization and then have post-Holocaust where they can invent anything they want to, because everything else has been, except maybe a few relics has been wiped away. I don't do that. I build on the real history as Heinlein did, and try to go from there. And that's actually all I'll say, because we want to have time for questions.
I think you answered my question, but I'm still going to ask you the question. How would you write the history of creationism? Because we have in the past, more like science fiction, we have mythologies and magic, and then religion came in too. So how would you explain it? Just through natural laws? I mean, when you look at the nature, it's so intelligent, you know.
Okay, how would but there's a couple ways of approaching it. I do have some religions in my future history. I have something called the Church of the New Reformation, which takes over Mars around 2100 or thereabouts. And I look at the Jerry Falwells and the Pat Buchanans and all of that, and even go back to Billy Sunday and other people like that, and see how they were able to accumulate power and money and all of that and do their stuff. And that's how I imagine the religionists in the future that arise do it. Oh God. Can you still hear me? Yeah, I'll just do it this way. Oh, they already do, but they cost. As to how the mythology develops, they generally borrow from the past, because there's a rich history of mythologies that nobody knows who created, or in some cases, like in Scientology, they do know who created it, and whatnot, and they borrow from each other, and and file the serial numbers off, and maybe change the names and whatnot, and have something else like that. But people have been suckers for that kind of thing forever, and probably will continue to be. Yes.
My name is Roy Elder, and there's a physics type of thing that we use for going farther and farther out in the solar system called gravity assist.
Yes.
And when you were talking about the sails,
Yes.
it conjured in my mind a phrase that I haven't heard of before, but it works for me. And I was speaking out loud. Wouldn't you call that momentum assist as a function? Does that make sense?
And actually, the term is momentum transfer.
Okay.
And that's a real description of mass beam propulsion as a form of momentum transfer propulsion. That's where you generate the momentum of the exhaust stream somewhere else other than the ship, and it can be light, or it can be particles, and if you're trying to move planets, it could be asteroids that do attractive scattering.
Yeah.
But yes.
I'm just using the gravitational momentum assist to think of from the gravitational assist. So I'm just putting those two together as a model.
Yeah. It's a real technique. You don't get very high velocities that way. But if you're limited in the amount of chemical propulsion you can buy, that's very helpful to get something out there. Hopefully in the not too distant future, we'll be able to push things so fast that the gravity of planets becomes, afterthought.
There's no question about the amazing advancement of science in the last few hundred years. But when we become extinct in the near future, all that information will be moot. Personally, I think Homo sapiens was a big mistake.
Well, one of the reasons that I did that present on the future thing is that I'm also part of a group called Contact Cultures of the Imagination. And we imagine other beings other than Homo sapiens. Because Seth Shostak. Has anybody gone to one of Seth's lectures or whatnot? He's on our board and been a speaker many times there. And we'll have the next Contact Cultures of the Imagination next year, I think second week in April. There's a website, www.contactconference.org, or you can just Google Contact Cultures of the Imagination. That should get it. The point here is we try and imagine all sorts of different intelligent races arising in the universe, and are we going to meet them? And frequently people bring up this, well, maybe intelligent races destroy themselves, or kill themselves in wars, or ecological disasters, or something of that nature. And the ones we meet are, by definition, going to be those that didn't do that. There'll be ones that found a way to survive. I'm hoping that we're going to be one of the ones that finds a way to survive. Yes?
Suggestion, you may want to rethink your writing parameters. You mentioned, for example, the speed of light, not going outside of that framework. The Chinese, about a year ago, I think, they shot photons up to a satellite much faster than the speed of light, so they've broken that barrier, and it has to do with Einstein's discussion of entanglement.
I'm sorry to, that is not even wrong, as it goes. They did try to get quantum entanglement over a distance, and possibly succeeded in doing so. Lorentz transformation doesn't say you can't do that. It says that if you do it, it's time travel. And it's very easy to prove that it's time travel. So if they're really being able to send information into the past that way, they're going to get very, very rich. I'm not holding my breath.
Yeah, this is, it's kind of goofy, but I read that Star Trek, when it was ready to go on the air, they got a bunch of scientists. Werner von Braun, I think, was the main thinker, is what is possible 30 years from now? And they almost got all of it right, except for, I just see if you beaming the person down to the planet, taking putting it, everything else to diagnostic bed. And then the other thing was, this is totally silly, but one of Woody Allen's books, this magician could throw you into his magic box, and you would be in the book that he put there. So these people were showing up in the wrong book in chapter 3. It was goofy.
Okay, the latter we can do with virtual reality. If you think about it, not quite holodeck rigor yet, but you go in a room with projections all around you, and you'll be in somebody's novel. That's entirely doable. And I think the Star Trek Next Generation holodeck things, they go in directions that don't sound very plausible to me, but the general sense of it is, yeah, that's going to be the future of entertainment. What was the first one again?
That was the first one.
Okay, what was the second one?
Woody Allen in the book, or how accurate Star Trek guessed what happened 50 years in the future.
Okay.
Mary, repeat it so I can get it recorded.
I'm having short-term memory issues, right? I thought the Woody Allen thing about showing up in the box, that was what I dealt with there. The one that was before the beaming. Oh, okay, the transporter beam and all of that. Oh, okay. the closest thing we can think of doing that is being able to scan you down to the atomic level and then print you out at the other end. I've done a couple stories based on that, but it's very, very challenging in terms of data processing capability. People are doing atomic scale printing now. It doesn't look impossible. But there's a lot of engineering work to be done.